Should we start?
Yes.
So, greetings to all. This is the team from Government College of Engineering, Nagpur, and we have completed an internship under EMERTXE. This was in IoT, and the project we have created is home automation using Arduino Uno in Picsimlab. Moving further, let's get introduced to our team. With us, we have Purvesh, Aman, and myself, Janvi. We all are from electronics and telecommunication, and we are all are in third year. Further, we will see into the table of contents. We will see C and C++ programming, then embedded system, characteristics of it, then Arduino Uno, Arduino IDE, Picsimlab, BLYNK IoT, virtual serial port, and then its working. So what is C? The language of embedded. Embedded C is an extension of C language. This is the programming language which is used in development of hardware architecture. Moving further, so why to learn C programming? C programming is easy to learn, structured language, and it produces an efficient programs, and it also can handle low level activities, and it can be compiled on variety of computer platforms. Next slide. In this slide, some basic commands of C language are given. First here is the header file. This command includes some standard input-output header files from the C library before compiling the C program. Then the main function is given. In this, we can write whatever we want in our program, like what we have to print in this. Then if we have to return from program, then we will write here return 0. Then next slide. In this slide, the structure of C program is given. First, we put the director as a header file. So then the main function, as we can see in the earlier slide, here is the print function and uh, in next slide. So what is C++? C++ is a high-level general-purpose programming language created by Danish computer scientists as an extension of C programming. C++ is one of the world's most popular language, and and in today's generation it is used in most of the operating systems like Windows, Linux, etc. etc. Next slide. So, what is embedded system? An embedded system is a combination of computer hardware and software designed for a specific task or a function. Embedded system may also function within a larger system. So that's what an embedded system means. Next slide. Here are some applications of embedded systems are given. The applications of embedded systems are industrial machines, then medical equipments, cameras, digital watches, household appliances, then airplanes, etc. etc. Next slide. In this slide, we will see some characteristics of embedded system. The main characteristics of embedded system that they are task specific, and it contains a processor that can either be microprocessor or microcontroller. An embedded system in a larger system to perform a specific function as they are built in for specific tasks within the systems. Next slide. Here are also some characteristics of embedded system are given. So for the further explanation, I would like to invite my teammate to take over the presentation.
Thank you, Janvi. Hello, my name is Purvesh Sonone, and I am going to explain the further presentation. So, as we know, our project is about embedded system, in which we are making home automation using Arduino Uno. So, first of all, we'll include that what is Arduino Uno. Arduino Uno is an open source microcontroller board which has a microcontroller at Mega 328P, and it is developed by Arduino.cc in the year of 2010. Arduino board has 14 digital pins, 6 analog pins, so that we can interface our uh, external peripherals to it, to the digital pins which are given, and 6 analog pins, and also there are PWM pins which is stated there with a tiddle symbol. So Arduino IDE, in which we program our Arduino. Arduino IDE is an open source software in which we write the code, and then we upload the code to the Arduino board. So Arduino IDE is suitable for different operating systems like Windows, Mac operating system, and Linux operating system. It supports the programming language of C and C++. What is IDE? The IDE stands for Integrated Development Environment. Integrated Development Environment, in which we can write our code, and we can upload our code to the board using Arduino IDE. So this is how the Arduino IDE looks like. In this, the uppercase is of a tool. This is the this is the toolbox. Here this right button includes that our file has to be verified, and this arrow is to upload the program to the board, and this is the file edit sketch tools. About to add a new file and edit some peripherals. This is the void setup, where we initialize the pins of Arduino, and this is the void loop, which always going to run repeatedly. So the next thing is Picsimlab. In Picsimlab, it is a emulator development board with a X MPLAB X AVR GDP debugger integration. Picsimlab supports a microcontroller from Pixim AVR, MUSI SIM, and other sim. Piximlab has integrated integration with MPLAB and Arduino IDE for programming the microcontroller board. So basically, Piximlab is a emulator where in which we can use the Arduino board. Just we know that we are not using the real Arduino board, so we are using Piximlab to initialize the Arduino board. So here's what Picsimlab looks like. The uh, This is the Arduino board, and these are other external peripherals uh, use which Picsimlab gives us to see our output indications. Then we are using a BLYNK IoT software, which is a cloud server, which is used to connect our peripherals by using any Android or iOS phone. So by using just a big Piximlab application and some BLYNK app and some BLYNK libraries, we can wirelessly connect our board with a wireless connection through the mobile phone. So then we are not we are not using any wired connection, so we are using a virtual serial port. What a virtual serial port is? Virtual serial port is a software representation of a serial port that either does not connect a real serial port. So this is not a real serial port, just like RS-232 or other serial communication ports. We are not using that. We are using a virtual serial port in our project. Then the basic workings of our project is, uh, we can on and off the cooler by using this cooler button. This is the cooler, and we can also on and off this the heater using this heater button. And the temperature this is the display to display the outputs, like temperature, the cooler is on or off, and other the volume of the tank. This is the virtual tank. In our project, there we are using a water tank which is virtual. In real life, we can connect this. We can connect using the real water tank, and here in this display the volume of the water tank, that with how much water is filling that volume is indicated here, and the output and input flow of water is indicated here. This is the Ethernet port. This is the temperature sensor. This is the LDR. What is LDR? LDR is the light dependent resistor. So the resistance of this LDR is increase or decrease by using the intensity of light. This is the LEDs, uh, LEDs which are connected here, and this is the driver IC to which is used in uh, to initialize the display. Then this is the water output and water input flow. So this is the virtual output. From here the input to the water is coming by when we on this input wall. So this the water fills in the tank, and when we off this, then water gets stopped. When we want to bring the water out from the water tank, then there is the output button. When we click this output button, the output the water flows out of the tank. So by and again clicking on that button, so the output flow is also off. When the tank is full, that is the volume is up to 3000. So when it is the tank is full, so it gets automatically off, and the notifications about that are shown here. So thank you. That's all with the presentation. Now we are going with the live demonstration of our project, which will be explained by Aman.
Okay, thank you, Purvesh. So let me just connect my phone so that we can share. Okay, so this is our Blink app. There is a cooler button, a heater button, a temperature gauge, a notification bar. There is an inlet button, outlet button, and a volume gauge for our serial remote tank. Okay, so as explained by Purvesh, this is our Arduino board. There are tools and spare parts which we can use. So yeah, so let, let me turn on the cooler. Sorry, first we'll turn on the heater. As we can see, heater is turned on, and temperature is increasing, which is shown on our LCD display also. So after reaching 35 degrees Celsius, the heater will turn itself off automatically, and which can be shown here in the notification bar. So we will turn off our cooler, turn on. So yeah, as you can see, the cooler is turned on and the temperature is decreasing rapidly. Now let's go to our water tank. So as you can see, after turning the inlet on, the water starts filling and the water gauge shows us the value is increasing. And as you can see, as the water reaches 3000 liters, which is the tank is full, it will turn itself off automatically, and it can be shown here on the notification bar. After turning the outlet on, the water will start going out and the volume will decrease, which is shown here in the gauge, volume gauge. And when volume reaches less than 2000 liter, it, it will start automatically filling on the water tank, and it is shown on the notification bar. So yeah, that's from our side. That's it. Thank you all for listening to us.